Hey everyone, this is Matt with Learn Everything About Design, and in today's video, we are going to take a look at creating a parameter-based design. Now, this isn't a configuration tutorial, it is really just looking at creating something based on parameters that we can configure and move. We're not going to be doing anything with sort of these logic statements like if-else statements. We're going to focus solely on the way that we're going to design the object, in this case a set of drawers, and we're going to be using those parameters and some functions inside of them, like relating different parameters together, in order to get something that we can create a robust version of. Now, so the thing here, and I'm going to go through a couple of changes. For example, here, if we increase the number of drawers we want, you can see it adds another drawer. If we change the overall drawer width, it'll make all of them narrower. If we change the total height, let's see, 150, it'll make them taller. And so what you can do with this kind of thing is you can create a robust model that you can be sure how it's going to update, how it's going to change based on the way in which you model it. Now, there are some things that we always have to consider when we're making a configurable design like this. And I say configurable, but again, we're not using configurations. Those have different sort of rules and implications. If we do configure a design, we can configure the parameters and we can tweak those kinds of things, suppress and unsuppress certain features. But again, the root of this, whether you're making a configurable design or you're making something like this that is truly parametric based on those user parameters, is understanding how it's going to update. All right, so we're going to have two focuses of this video. One is building out and understanding the basics of parameters, which we've done in a couple videos. At this point, they're a couple years old, so we're going to just sort of rehash that topic. And the other is the approach to modeling. And the approach to modeling is extremely important because how you model something for updatable parametric design like this is actually different than the way that I would model it if I were just going to create this design and I knew I needed 4 drawers and how we're going to build it. Now, each of these drawers, I did also build in something like a gap for 3D printing. So you could 3D print these designs or make something similar. Every time Fusion restarts, it kills me with this. It disables the enable camera pivot and it changes my orbit. So I always have to go back in here and change it. I don't know why that is. All right. So to get started, we're going to use this exact same example because I think it helps highlight some of the things that we need to understand. And so we're going to start a brand new design. If you haven't switched to intent-driven design yet, where you see the part design, assembly, hybrid design, you will be using the hybrid approach by default. Today is January 19th. I believe this week, the intent-driven design will be the default for everybody. So if you haven't done it yet, and you're watching this video the day it's recorded, if I get it up today, then you want to make sure that you understand the differences here. Part design means that all of these are going to be bodies. In reality, this is an assembly, but the way that I'm designing it, they're just going to be parts or bodies that are inside of one part file. If you're using a hybrid design, the same approach will hold true. You'll just be using bodies inside of that. You could then convert them to components. Again, I'm not going to worry too much about that for this video, but just something to keep in mind. Okay, so the first thing when we have a design like this is we need to figure out the parameters that we want to control. And so I'm going to go into modify and change parameters. I'm going to bring this up because we're going to be creating a lot. And then we need to start defining sort of the base things, the base numbers that we want to use to control this. So we're going to hit the plus icon. This thing pops up all the time. If you don't make videos like I do, then you can just click do not show this again. I always have to leave these pop-ups because if I don't and somebody's following along and they see that, they'll think that there's something wrong. Ever since parametric text became a thing, that's now going to pop up the first time you hit to create a parameter. All right, so the first one that we're going to do is I'm just going to call this one drawer width. Now you'll notice that I used a capital letter for W. You can also use an underscore. Either one's going to be fine depending on how you want to see it. Just keep in mind that you can't have a space in here. If we try to do width, you see there's a red line that shows up. It does not allow you to have a space in here, so it needs to either be an underscore or just a capital letter for the second one. A drawer width is going to be a value that's in the unit system. In this case, we're using millimeters, a metric system. So I'm just going to enter 100 millimeters. You can add a comment if you want. We're going to say OK. One big difference between creating a user parameter and naming something in a model parameter, if you're, say, in a sketch, it's going to essentially create a parameter inside of a feature and then automatically tag it as a favorite. So it sort of just highlights that star for you. They behave the same functionally, but they're kind of in a different area. It'll be in this favorite section and not in the user parameter section. All right, second thing. We're going to do drawer. I'm just going to stick with the underscore now. Depth. So this is going to be how far back it's going to go, and I'll use 200 for that. And then we'll do one more here. We're going to do this drawer. At some point, I'm going to misspell this. I know I am. And we'll do drawer height. And I'm just tabbing over to the next ones here. And so the height, again, make whatever you want. I'm going to make mine 100. Keep in mind that anytime we're designing something like this, there will be a limit. You need to understand where that limit is. I'm not using any sort of upper and lower bounds or logic to prevent me from creating a model that doesn't work. That's just something that you need to be aware of. If you want to include a range like that, what we've done in the past with other designs, so for example, a year or so ago, I did a sheet metal barbecue smoker grill for an Autodesk dataset. And that had to be a configurable with parameters, but configurations actually wasn't a thing yet. So basically what we did is we configured everything based on a 1 or a 2. It was basically just you entered a number. For the smaller version, you entered a 1. For the bigger version, you entered a 2. And then all of the rest of the parameters were based on that. If the value is a 1, then the length is this. If the value is a 2, the length is this. And that was just a way that we kind of got around that. So you can enter some of that logic in there with like sort of true, false, 0, 1 kind of relationships. All right, a couple of more base numbers that we want. So we're going to have, you can call this whatever you want, but I'm going to call it a housing underscore offset. And so this is going to be the distance between each drawer and between the drawer and the outside. And I'm going to make it 10 millimeters. Again, you can make it bigger or smaller. But this value is important because it's going to be what helps us figure out the overall width or height of this thing. And then it's also going to help us figure out from there the like the spacing to the back, for example. So it's going to be important. And that value, we only want to drive it with one value. You could, of course, have different widths on the side, but then the formulas just become a little bit more complicated. It's a bit probably too complicated for what we're doing here. The next thing that we're going to do is drawer number. This is not a millimeter. This is a no units. And I'm going to start with 5. And so it is important if we enter something like a degree value or if we enter something in a different units that we capture that. So there are more units down here. So for example, pieces. So some of these will come into play if you're talking about certain features. And so what I mean by that is if you are, let's say you're creating a formula that's going to control something in flat pack layout in manufacture, you may need pieces as whatever the value is looking for in the dialog box. So you just need to make sure you match that. There will be some unit conversions that do have to happen sometimes. So for example, if you're trying to use drawer number as a driver for a width, you may need to multiply it by 1 millimeter or 1 inch if you're using the inch unit system. In this case, it'll be fine for us, but just something to keep in mind. The last value I want to put in here is I'm going to put in a print tolerance. And that value, generally 0.4 is a pretty good tolerance. Keep in mind that this is going to be completely around the drawer. So it'll be 0.4 on either side, 0.4 top and bottom. So it's actually closer, it'll be 0.8, so closer to a millimeter gap. But when you have something like this, let's say we do make a drawer that's 100 millimeters or 200 millimeters deep, you kind of want a bigger gap between that. And you can, of course, add more features if you want a sort of a tongue and groove feature to keep the drawer centered. You can add all that stuff. But this parameter, again, you can change it at any point in time. This helps us because when we extrude the actual drawer, it will also prevent it from touching any other solid body, and it'll prevent it from trying to join it by default. So it's kind of a nice feature. Okay, So these are all of the basic user parameters that are just controlled by numbers. Now what we need to do is we need to have a couple of formulas that are going to control the other dimensions. And so when we do this, I'm going to pull this down so we can still see all the stuff up here. All right, so when we do this, the next thing that we want is to understand what the total width is going to be. So I'm going to use total width. And the total width is, we're going to have to start using brackets and inside of this formula. And actually, can I drag this to the right? Yeah, let's drag it to the right so it's a bit wider. All right, so this is going to end up happening in sort of two chunks, okay? So what we're going to do is we're going to take the drawer width, which is 100. I'm going to click on it, and we want to multiply that by the number of drawers. And so we have that defined as drawer number, and it's unitless, and we're going to close the brackets. You'll notice the bar underneath it is blue now because it's valid. If we take away that bracket, it's not valid. All right, so we can see this is 500 millimeters. But this isn't everything, because what we actually need to do is add in the spacing, the housing offset. But we need to add in the housing offset for each space between the drawers and on the outside. And so in our case, we've got 5 drawers, which means that we need 6 spaces. We've got 4 spaces between the 5 drawers and 1 on either side. This sometimes can be a little trippy to think about. You may need to draw it out and in a sketch or on a piece of paper, but that's generally the rule. And so this is going to end up being in 2 brackets. And what we're going to do is we're going to take the drawer number, which is 5, and again the red bar underneath says that it doesn't have a valid solution yet. We're going to add 1 to that. All right, so that gets us from, in this case, 5 drawers to 6 spaces. We're going to close the bracket off. We still have 1 open bracket. And then we need to multiply that by our housing offset. So I'm going to close brackets again, and I'm going to use housing offset, and then I need 2 brackets to finish that off. And so basically what we have is 1 set of brackets for this entire function there, which takes our drawer number and adds 1. So we have 6 gaps, and we multiply that by the 10 millimeters. So we get an extra 60. And so you can see here that we calculated the overall width, and then we added all the gaps that we need. All right, so again, we're not using any extra logic, any if-else statements, any upper or lower bounds or anything like that. But we do need to think through, again, how we want to build this model out and how we want these numbers to relate to each other. All right, so just a couple more. These will be a little bit easier. I'm going to just pull this over to the side so we can see these pretty easy. So the next thing that we want is a drawer total depth. And I couldn't use drawer depth because I already have that. And so what we want to do here is we want to take this 200 millimeters, which is the drawer depth. I hit tab. We're going to take that one, and then we want to add our housing offset. So we're going to add that 10 millimeters. So what this does is when we're building out the outside of the shelves or the drawers, we're taking the 200 millimeters, and then on that back side, we're adding another 10 so that we've got a consistent 10 millimeters between each drawer and on the back side. And so that's going to be our total drawer depth. And then we need another one for the total height. And I'm going to just do total drawer height. And so this is going to be the same one. So we're going to take the height this time, and we're going to add the housing offset. This is one that's a little bit tricky because on the back, the drawers will be open to the front, or rather they'll just be there. But for the top, so if we're making this thing, let's pull it off to the side again. If we're making this thing 100 millimeters tall, we actually need to have 2, a top and a bottom for the housing offset. And so that's going to be a consistent number because we're only doing 1 drawer high. So what we can do is in brackets, we'll just say 2 times, and then this is going to be our housing offset. So that should give us 120. So that's going to give us 10 at the bottom and 10 at the top. So that'll be okay. And then we need to do 1 more. And this next one is going to be our drawer PAT for pattern spacing. All right, so we already know the number of drawers, in this case 5, but when we're building this out in a a feature, in this case, a rectangular pattern or a linear pattern, then we need to know how far each of these is going to be spaced. We already have all the numbers. We know the overall width because we calculated it here. We know the number of drawers here. We know how wide the drawers are, and we know the spacing that we want. And so basically what we need to figure out is from the corner of the first drawer to the corner of the second drawer, how far are they? Well, that's going to be our drawer width. So I'm going to take that value, and then we're going to add our housing offset. And that's it. We're just going to add it once, because if we have a 100 millimeter wide drawer and we want the next one to be that plus 10 millimeters, then we just use that. And now we can modify any of these numbers we want. We want to leave the formulas alone unless we need to change some functionality here. But we can modify things like the the overall width. Let's just go ahead and do a test. So I'm going to change this to 150. And so you can see the pattern spacing changes to 160, the overall width changes, and so on. And so we're gonna reset that to 100. All right, so now that we've got all of these, the other things that are going to happen in sketches and features is we're going to relate back to these. So for example, the print tolerance is going to be used for an offset sketch. The drawer number as well as the drawer spacing is going to be used in a feature pattern. And some of the other stuff will just get used in sketches. All right, so now the second part of this. This is where we have to plan out how we're going to model it. So we're going to start a sketch. I'm going to use the front plane, so the drawers are looking at the front. And typically when I start a model like this, I would use a center point rectangle, and I would begin building using symmetry, because in 99.9% of the cases, that's how you want to design a model. Whenever you can, you want to be symmetric about the origin, or at least symmetric about one of the axes. However, when we're trying to build a robust model that we can change things like the number of drawers, that complicates things, because in a situation, and I'll just go ahead and just do a quick sketch. We're not going to add any dimensions here, but in a situation where we've got, let's say, 3 drawers, then what ends up happening is you've got one at the center, and then we can pattern them left and right. So we can use a symmetric pattern. And that's an option that we have in linear pattern, circular pattern, things like that. However, the problem happens when there's only 2 drawers, if there's an even number. So what you end up having to do to build a model in this way is either use configurations where you can suppress a feature, or do things like if statements inside of the user parameters where you have to determine if the number is even or odd, and then change out the formulas for that. So it becomes a really complicated process. And honestly, if you're designing a model that is just going to use those parameters to update, it doesn't really matter as much that you're basing it at the origin or symmetric about the origin, as long as you understand how it's going to update. And so the way that I would build a model like this is from the origin, we want an anchor point, and I'm going to build up into the positive coordinate system. And so I'm going to start by doing, let's see, what did I call this? Drawer height. I'm going to tab over to the next one, and this one is going to be drawer width. Actually, sorry, that's not true. This one is going to be total width. Okay. And you'll notice that as I move the cursor, it makes it negative and positive. You want it to be in this positive coordinate system, and then we're just going to hit enter to accept, double click the mouse wheel, and then it'll kind of fit the screen. So this right now is going to be the basis for the entire front face of the drawer. So it should have the right number of spacing for the offset and everything. And so again, historically what I would do is I would start to draw out the drawers and potentially pattern them in here. But it's important that we do things with feature patterns when possible. It'll be more robust, the calculations will be better and quicker, and we don't have to worry about things like selecting sketch profiles. So if I happen to, let's say, just draw one of these in here and dimension it and then pattern it, and let's say at one point I decide that we want 3 drawers, and then one point we want 4 drawers. Well, if I pattern a feature that's cutting material away or adding material, that's easy to pattern. But if we had it at the sketch level, we'd have to come back and reselect profiles. If we go from 3 to 5, it would simply omit those other two. And so these are the things that we have to think about that slightly change when we're trying to make a model that is configurable or controlled with these parameters. And so what we're going to do is we're going to finish the sketch, double click the mouse, and we're going to extrude this. It's going to come back in this direction, but again, we want to link it to those parameters. So I'm going to start to type in drawer, and this is going to be its depth. Actually, I'm sorry. Let's see. This is going to be total depth right there. I always want to make sure we use the correct ones. And so right now we've got a sketch that is giving us the total width and the total depth. So the next piece of this puzzle is to start to create the holes for the drawers. So I'm going to sketch on the front face, and I'm going to create the first drawer, because in this situation, there's never going to be a situation where we don't have a drawer. It's always going to be at least one. So I'm going to draw that first one, or that seed, and then the rest will be created in a pattern. And so we use dimensions from the bottom. This is going to be our offset. And I'll just hit enter. I'm going to hit escape and then pull this down, and then dimension again. Now we could click to this one and relate it to that dimension if we wanted to. It's better for us to do, let's type in offset. It's better for us to link it to the actual parameter. There's probably no difference in terms of the calculation, but in terms of the cleanliness of the back end of it, I think it's better for us to do this, because if we just click on this dimension, then we end up with this one linked to dimension 16. If we happen to remove this dimension, then it breaks that link, and the model is not going to be as consistent. And so we also need the drawer width. So this is going to be drawer width. Hit enter to accept, and then we're going to finish the sketch. And then now what we're going to do is we're going to extrude that back. It's going to go this direction, so it's negative. So we'll have to use the negative sign, and this is going to be our drawer depth. Now remember, for the depth, we added that offset, that 10 millimeters on the back. So it's going to leave 10 millimeters back there. On the height, we added 10 to the top and bottom to make this original extrude. And so everything should be fine in terms of the spacing. This should be 10 top to bottom, 10 left to right, and 10 top to bottom here. So now what we can do is we can go to a pattern. We're going to pattern the feature, which is this extrude cut. The direction is going to be x-axis. We're going to start to drag this out to the right, and then we want to change our distribution to spacing. And then for the quantity, we want the drawer number, which is 5. And then for the pattern spacing, we're going to do minus pattern spacing, this one here. And we'll hit enter. And so this should give us, that's hard to see there, but that should give us equally spaced drawers with 10 millimeters between each one. So if we measure from here to here, we should have 10 millimeters, and that it should be the same everywhere. There shouldn't be any difference. And then if we did the math right, it should be 10 millimeters to that side. So everything looks good there. It's also a good idea at this point, before we get too deep into building out more features, is to go back in and just double check that you didn't break anything. And so if we set this to 4, it works fine. If we set it to 6, it works fine. And so it's always a good idea. Let's do drawer width, 125. Let's update, go down to 50, and they update, and then we'll go back to 100. And you can do this with other parameters too. So if you want to change the height, you can do that. I'm just going to leave them at the default numbers that I put in there. But again, it's a good idea to do sort of the sanity check. All right, so now that we have this, again, we're going to go back to creating this first one. We know in all versions of this design, we're going to have at least one drawer. And so I'm going to start a sketch on this front plane. We're going to create a sketch. Keep in mind that this can get a little dangerous. What I mean by that is this sketch is bringing in all of the surrounding edges of these pattern features. And so sometimes, if you find that there are some rebuild errors or rebuild issues, sometimes you might find that you want to do this step before the extrude cut and the pattern, or actually before the pattern, but after the extrude cut. That way there's only one edge here, and the face, the edges that are projected into our sketch, only include this one here. Now, it should be fine in our case, but again, just kind of a word of warning. Sometimes I've seen updates not behave as intended because things like the edges, the actual identifier in the back end changes, and it could mess with things. But in this case, let's just run with it and we'll see. So what we're going to do is create an offset. This is going to be our print tolerance. So this is going to give us that 0.4 millimeters, and we're going to finish the sketch. Next, we're going to extrude this as a solid body. And as we go back, I didn't create a parameter for this. And we can do this on the fly if you want, but sometimes it's best to go back and create a parameter. But what we're going to do is for the distance, we're going to say minus drawer depth, which is 200. But then that's going to take it all the way to that back face, and it's going to try to join it together. So then what we're going to do is we're going to subtract the print tolerance. And so what this will do is this is going to, actually, you know what? We're going to add the print tolerance. Let's try to add it. Yeah. And so what this will do, we can't really see it anymore, but what this will do is it'll ensure that we have that gap between the back, and it'll prevent it from trying to join it to the next one. We're going to pattern this as a body, so as long as this first feature works out, it's not a problem. But Fusion can get a little tricky sometimes if you create a feature like this, and let's say you extrude it when other things are hidden, and when you rebuild it, things are visible. Sometimes it has a tendency to join those together. It's not all the time. I'm not sure if there's a certain thing that triggers it in the system, but in this case, that 0.4 millimeter gap all the way around will help us. Notice there's a little FX here because we're linking to parameters, but we created that relationship directly in the dialog box. It's totally possible to do that. And as long as we go back and change the drawer depth or that print tolerance, those values should all work out fine. What I'm going to do now is I'm going to hide the body, and I'm going to use the shell command, and I'm going to use the housing offset. You can make a 10 millimeter wall. You can also do mathematical operators inside of here. So for example, if I wanted to divide that by 2 and make it 5 millimeters, but I still want some relationship with that 10 millimeter offset, we can do that here. And this will leave us with a consistent wall. And so if you want to print this drawer, pretty simple in this orientation. You will need to have some sort of drawer pull. In the first version I showed you, I did this little extrude. If you are trying to do like a 3D print, it's probably best to do a hole in the front. And that's just simply based on the fact if you're printing this, it'll be easier to have the hole. You won't need any support for it. So for this version that we're doing now, I'm going to create a hole. And so what I would do is create some reference lines. Now this can be, so for example, you can just find the midpoint here and do that, or you could do from the corner. But essentially what we want is we want a center location. So I'm going to do a hole, and let's make this one 20 millimeters. And then we're going to do an extrude cut. And so what I'm going to do is I'm going to say minus housing offset, because I know that the housing offset divided by 2 is how thick that wall is. Keep in mind, this is one of those things where it gets a little tricky simply based on the fact that we entered that formula directly in the dialog box as opposed to creating it as a user parameter. So if you decide to go back and change that from the offset divided by 2 to just the offset or divided by 3, then this won't work anymore. The other way that we can get around that is to create a parametric relationship by just doing toObject and selecting the inside face. If the shell feature changes, the extrude up to that face will still be fine. Now I'm also going to toss a couple of fillets on these front edges just to round it off. If you're sticking your finger in there to open the drawer, then you want to make sure that it's not a sharp corner. It should still print fine like that. You might have some issues at the top here. You may want to use an ellipse or something. But again, I'm not 3D printing this, but just to kind of give you an idea. Okay, so now that we got that first one, I'm going to rename this drawer 1, and we want to pattern it. So again, this time we're going to pattern bodies. The direction, still the x-axis. We begin pulling it this direction. We'll use spacing, and then we'll use the pattern drawer number, what is it called? You think even after giving these nice consistent names, I would remember. And then this is going to be our pattern spacing. All right, and we'll say okay. So now we got 4 drawers in there. And if I go before this, I'm going to just change its color here. So A on the keyboard, let's just use plastic. A on the keyboard is the appearance command, and we'll just give it green. Green's there. All right, I think it should inherit that with the pattern. Nope, of course it didn't. All right, anyways, we can still see the first one here. So now let's go back into our parameters and let's change a couple things. So let's say we want 2 drawers. Seems to update properly. Let's say we want 10 drawers. Okay, it did inherit it. That's weird. Okay. All right, so the number changes just fine. If we change the height, we can make them taller. Zoom out a bit. If we change the depth to 100, they're making them shorter. You can see there's still all the drawers here. Let's go ahead and make it 250, which is about the size of a print. Actually, that won't fit on most printers. We'll make it 200. Drawer width, make these super wide, and you can see all these work. Now, if we happen to start changing other things like the housing offset, let's say I want an inch between them, you can see that it adjusts everything. The drawer sizes change, and now we've got that offset value. If we want the print tolerance to be bigger, if we want these things to slide in and out easily, let's say 0.6, it's probably hard to see. Actually, let's make it something bigger. Let's make it 2 millimeters. So you can see it's leaving a larger gap there. And so if we go back down to 0.4, again, that's on both sides, so it's closer to a millimeter, and that's probably plenty for this, but obviously this is kind of oversized for what we're doing. But you can make small versions of these. So for example, if you want to organize things like little resistors or electronics components on your desk, then you could just tweak and configure this. Now, there's obviously more that could be done. We could have this be multiple rows, so it could be like in this case 5 by 2, so you have 2 stacked, or you could change the shapes of the drawers so that it's not just a rectangle. But the core of this is that there's two major steps that we need to understand. The first is the parameters that we want to drive our design. In most cases, the bulk of the parameters that we're changing are going to be simple numbers. So a width, a height, a depth, some sort of numerical value like a pattern number, print tolerances, things of that nature. And then we need to understand how we want to rebuild the design. So for example, the overall width. We need to account for the space in between each drawer in this case. And then we need to go through and figure out which values, in this case our housing offset, the drawer width, the drawer number, and build out some sort of equation that accounts for all that. Same thing with the depth, the drawer height, the housing offset for the pattern spacing. And in this case, a fairly simple example, but it can easily get pretty complicated once you try to add more functionality. Once again, that was just a portion of it, understanding the numbers, the numerical inputs. The second is how you actually go about building the thing. And this is where it usually hangs people up, because building something that is going to be updated based on the parameters oftentimes is slightly different than how you might model it to just model it. And so many designs can be centered at the origin and still work. Some designs will need a different approach. Like this one, the ideal situation is to ensure that this is built in that positive coordinate space rather than centered at the origin. And just because it gives us the flexibility to have even or odd numbers of drawers, whereas if we built it centered around the origin, it really restricts us to having an odd number of drawers because everything is building out in all directions rather than just building out in the positive coordinate system. And so hopefully that helps. This did not tackle configurations. That's another step in this process. But realistically, configurations opens up more functionality. So for example, you can do things like change materials, change appearances. You can suppress features or bodies or components in an assembly. And there's all sorts of things that you can do with configurations that you cannot do with just these user parameters. However, understanding the functionality and the way to build a model so that it can be updated consistently, that core functionality is important to configurations as well. So this is kind of like a primer or a first step. I'm going to go ahead and save this, and I'll leave a link in the description. If you have any questions or comments, please leave them on the video. If you like this kind of content, then consider subscribing. We will be updating our courses on learneverythingaboutdesign.com very soon. As soon as Fusion updates, we're going to be diving in and making updates to that content. And we will be including some new content throughout the year. And we always listen to your suggestions for videos. This is a video suggestion that came in from several people. I get questions on how to create a robust design with parameters. And so if you have those suggestions, the more people that suggest the same video, the further up that list it goes. So I try to get to it a bit sooner. So feel free to leave suggestions. I'll write them all down. I keep them in a list, and I'll get to them as soon as I can. But as always, thanks for watching, and we'll see you in the next one.